Me too, I'll be honest. It's why I became an engineer, because I want to solve a problem. I don't necessarily want to do lots of paperwork. So. But half the test is no calculator. So, and as Meredith noted, okay, the problem is not new. As you read the problem, it should feel very familiar because you practiced problems like this in the last unit. You were just able to use a calculator, now you can't. I do take a different approach than a lot of teachers, though. A lot of teachers will expect you to remember things that you learned like in 9th grade, 10th grade, etc. And I personally found it difficult as a student to remember that. So I've tried to figure out ways to solve problems with remembering as little as possible from the ancient days. Like we have to remember things from this year, but I do try to give ways to help you solve the problem without remembering as much, because I find it better. So if you like to remember all the old stuff, it's fine, it's just not my approach. I have to be honest with you, my method does have I'd say about a 1% chance of failure if they get really tricky, but they never have, it's never failed me, so anyway.
Not sure it corrects you.
Well, you're kind, but they're trying, but they haven't yet. So. Yeah, I'm serious, like every year I look at like every time they release a new AP test, I'll read through like, you dirty buggers. Like, you figured out a way to like make it harder for my students, and then like it makes me angry. So, okay, area. Key thing when you don't have a calculator, you just have to go really, really slow. The AP test is not a race. Let me show you some numbers. Okay, on the ACT, if you're trying to score high, like high 20s, low 30s, you have to get nearly every problem right. You cannot miss very many in any section. The AP test is completely different. There are 108 points possible. If you earn a 4, you will earn the maximum amount of college credit. For every university I've ever looked at, you don't get more credit for a 5. A 5's just like kind of feels great to do the best you can do. But a 4 is good enough for the max credit. If you can get approximately, it changes year to year just a little bit, like by a few points is all. If you can score about 60 out of 108, you'll earn a 4. Okay? So listen. That's why I will constantly remind you, it's not a race. You're not trying to get all the questions. You're trying to get all the easy questions first, because it's not ranked. Like the easy problems count exactly the same as the hard ones. They don't get more points for hard questions. So you want to learn to identify easy questions and get those done first. That's why you don't want to race. Just be methodical, just little by little. If you get stuck, you just calmly move on. Don't even worry about it. Just move on. Because there's so many points you can miss, it doesn't really matter. So anyway, working this problem, I would start reading, what is the area of the region? Go slow. The area of the region between this graph and this graph from x equals 0 to x equals 2. Honestly, the first thing I probably would have done is paid attention to this because it's the easiest part. X equals 0 is a line whose x coordinate is always 0. So do this or do this to indicate what this line looks like. Go. So stop for a minute. Think about what you're doing. You're trying to draw a line whose x coordinate is always 0. So do this or do this. The x coordinate, think of the line, go along the line and find every x coordinate and think of whether that x is 0. That's better. Everyone give yourself 2. I do too. In fact, for years I could never keep it straight until it occurred to me what I've been saying to you. It just didn't occur to me that this means every x coordinate is 0. So then I can remember now. Yeah, before I would always get the mixed up. So I have this. It goes back to the idea that I don't think of curves, I think of points. So when I see this, I don't think of lines, I think of points. Every one of these points, drawn very crookedly, every one of these points has a x-coordinate of 2. Every one of them. Okay. Let's see, the area of the region between these two graphs. Huge thing to memorize. When they give you two graphs and they start talking about the area between, I cannot think of, well, there are some exceptions, but most of the time you are going to have to figure out how those two graphs intersect each other. So you can identify how they contain some area. So you do have to remember from a previous class that to figure out where they intersect, you set them equal. It's an easy y. This is a formula for finding y coordinates on this curve. This finds y coordinates on this curve. You want the two y coordinates to be the same. That's where they'll intersect. So that's why you set the equations equal. Questions? Next step is also memorize. You don't solve when you have x squared and x by dividing. That you're going to get the wrong answer. You get everything on one side and you factor. Please.
Sorry, I know you answered the other questions.
You're fine.
Are going to be by those two equations to each other?
So this is an equation for finding all the xy pairs. This is an equation for finding all the xy pairs. So they're two different dots, curves.
So they're two different graphs.
Totally two different graphs. But I want to find out when the two graphs hit the same point.
Oh, okay.
So I want their y coordinates to be the same. That's a good question. 2 points. Now you factor. Now you remember, when we say solve an equation, what we really mean is find the x that makes the equation true. Find the values of x which will make the equation true. So don't say it out loud, just raise your hand and tell me what values of x will make that equation a true statement. What are the x values that will make that equation true? If you're struggling, here's what you should be looking at. You have two factors multiplying. That's why we factored. The only way for two factors to multiply and get 0 is if one or both are equal to 0. So I've just got to figure out what x values will make one or both factors 0. So what are they, Hannah? Okay, look.
-1 and 0.
So if I put a -1 here, this will be 0. This would be -1, but I don't care. This times this would be 0. If I put a 0 here, this would be +1. Don't care, so I'm good. So raise your hand, please, if you were prepared to say that. 2 points, 3 for Kate. Okay, as always, you can't get lost in the math. You have to keep track of the big picture. So raise your hand and tell me, what do these two things tell you? What do these two things tell you? What do these two things tell you? So Spencer?
Where those two graphs intersect.
Good. So we know that these two graphs intersect in two different places.
This is done in negative 1.
Oh, thank you. You just wrote that. 2 points for Gage. Sorry, that's -1. My bad. Okay, the problem's being a little confusing to me right now because these two curves intersect here, yet they want me to find the region between x equals 0 and x equals 2, but -1's over here. So I'm feeling a little puzzled. Straight up honest, if I were taking the AP test and this started to happen, I would move to the next problem. Because I'm trying to get the easy ones done first. And right away I'm feeling like, okay, I was doing great at the beginning. Like, okay, find area, set these equal, factor. Everything's feeling like I'm progressing normally. And then suddenly I feel puzzled. If I feel puzzled on the AP test, I do not want to spend time right now. I want to go do things that don't puzzle me. Get those done first, then come back. So I would move on. Question?
It's just so hard because I feel like when you skipping columns, I get confused with kind of going to the last one.
true. So that's why we will practice the AP test for pretty much all of March, all of April, so that you get more and more accustomed to how to correctly take the test. Yeah. It's a learned skill. It's like it doesn't come naturally because it feels awkward, but you get better and better at it. Just pay attention to your feelings. As soon as you have that feeling of like, I'm not making progress, you move on. Okay. We need to solve this one though. So then I thought, well, maybe I'm just going to have to know a little bit about what these look like. The good news is they didn't give something very complicated. So I draw some more. Okay, y equal negative x, that's easy. That's a line that looks like this. Roughly. Please.
So when they give you these type of problems, you now just have to know what the graphs are.
Hold on. Ticket question. I would say about 95% of the time you don't. We'll do another example in a minute. This one was one of those 5% exceptions where, yeah, I pretty much have to know that this looks like this, otherwise I can't solve it. But I'm going to show you another one, and then in the homework, I don't think there's a single problem in the homework other than this one that you have to know what the graphs look like. So, and I'll show you my method for that. X squared, I do remember that x squared looks like this. Okay. Now the problem does make sense, but Ava's correct. I don't know that I can make sense of the problem without remembering. But that's again why I show you this. I've been asked many times, would I get 100% if I take the AP test? And my honest answer is I don't think so. Because I think I'll run into things like this where even as much as I do calculus, they'll throw in something that I won't remember and I won't be able to get it. But I don't worry about it because you don't have to. So here's the first intersection right here. That's x equal negative 1. We don't need the y coordinate there. Here's the other intersection. I drew it kind of badly. X equals 0. Okay. Feel free to talk, but I would like you to raise your, I'm not going to have you come to the board, but I want you to raise your hand if you are confident you could come to the board and outline the area they're asking you to calculate. One thing you cannot do in my class, like I try to be really patient with everything, but cell phones drive me crazy. Like you can't sit in class and tune out of the discussion and think you're listening, you're not. Like the moment you pick up your phone, your brain switches. Multitasking is a myth. No one can really, I mean, simple things, yes, but you cannot learn calculus and text at the same time. The moment you start texting, your brain shuts off, you miss things. So don't do that. Please.
Would we be,
Yeah, raise your hand, please. Who can tell, like, see, it distracts the heck out of me, too. Who can come to the board and draw the area we're supposed to be finding now? Like, use all the clues and tell me. Who can come to the board and draw what the area would look like? Free to talk if you want to, but I need some more hands.
I know, that's what I was saying. I'm not sure. Because why does the intersection and not? Oh,
Show me your hands. No. Show me your hands. Kenzie.
is it just the region from 0 to 2, like the green line going this way?
It's perfect. Well described that. No, really, without having to come up and trace it, that was a good job. So Kenzie noticed, okay, look. It says the area between the graphs from x equals 0 to x equals 2. So we draw, my drawing's a little off here, but we draw another line here.
You did it in the last unit and you do the
So that blue space is the area. How many knew it? 2 points, 3 for 2. Question? Okay, once I get that far, now again, just helping you understand how to take the AP test, if I can get that far, I'm going to keep going for sure, because now it's, as we say, all downhill. I just need an integral, top minus bottom. So the integral I create looks like this. So I'm going to integrate from 0 to 2. The top equation is x squared. The bottom equation is x. Oh, I messed up. Raise your hand if you know my mistake. Macy?
The bottom line, the bottom equation is negative x, so it'd be x squared plus x.
Good call. So, I missed the joke in the back. Who knew it? 2 points. Okay. 3 for Macy.
Why does it have to be like that?
Say again.
Why is it, so, the equation, like, is subtracting it?
So we learned in the last unit that to find area, we integrate the top equation minus the bottom equation. Question? 2 for Ava. Please, begin.
So this would be considered like a long problem to do on the AP test.
Good question. Hold on.
It kind of just seems like
Cheering from the back and everything. Did you get one? Okay. No, good question. So what I'm doing right now is I'm kind of scanning my brain for comparison. Yeah, hey, look up. I would say I typically classify AP questions into easy, medium, hard. And I put this in the hard. Like, it's just enough thinking, it's enough having to remember old stuff from previous classes. I put it in the hard category. I've seen harder for sure, but it's up there.
I think it intertwines like things we've learned in previous years with calculus.
Oh, yes.
So it's like drawing on that, but not allowing that old information to take over, like retrospective.
No, well said, Sam.
Wait, can we use a calculator on this blue sheet or no?
Yeah, this whole unit is no calculator, so. Okay, next thing, look up. Okay, now from this moment on, it's not hard. It falls into the easy category. When you see 2 things being added, the first thing you should think of is I can find the antiderivative separately. So this becomes x cubed over 3 plus x squared over 2 bar 0 to 2. And all I'm using here is the fundamental theorem. So I'm using this exactly. Raise your hand if you can tell me what f is over here. Like I'm using this theorem, so what's little f over here? Hands, come on. Think with me. Don't ever come to class and just listen. You might as well stay home. Watch the video. Like you're here to interact. If you don't interact, you're wasting your time. Like what's little f over there? You can talk. I need more hands. Like you have to see how this formula relates to this. Because that's how we're getting from this line to this line. We're using the equal sign. We're making a replacement. We're saying these 2 things are the same. Well, I can't use this if I can't figure out how this matches with this. So what's little f on the board? We got to have more hands than that. This question that I'm currently asking you, if you can't answer this question, you cannot get 30 of those 108 points. Like that's how big this concept is. Let's go, Milan.
Is it x squared plus x?
It's perfect. So we are integrating this formula here. So we think of that as being small f over here. How many knew it? 0.2 from a long. Hands up, what's capital F? Come on. What's capital F? Elijah?
X cubed over 3 plus x squared.
How many knew it? 2 points, 3 for Elijah. Okay, hands up. How does little f relate to capital F? Come on. How does little f relate to capital F? Go Sage.
Little f is the derivative of
So little f is the derivative of big F. Now say it the other way around.
and big f is the anti.
So big F is the antiderivative of little f. Okay, how many knew it? 0.2 for Sage. Look, I'm trying as hard as I can to impress upon all of you that you are not doing math by moving pieces. You're solving the problem using the equal sign. You are finding out line by line what is the same as what. That's it. This formula tells you. It's what Sam just asked. If you can pick up your calculator, there's no reason for the fundamental theorem at this point. Just plug it in. But you can. So the fundamental theorem provides a way to replace this with something else. It's not, this doesn't become this. These two things are the same, according to this theorem. And so now we're going to do this instead. That's all we're doing. Please.
Sorry, I feel like I mentally missed step of how you got to from that first equation down to x cubed.
From here to here.
No,
From here to here.
The red line, yeah, that's one.
So what I did is I know I'm trying to solve this. I know I can't, so I want to do this instead, because they're the same. So I have to find the antiderivative of this. So I use my pink sheet, and remember, if I'm finding the antiderivative of two things that add, I can do it separate. So I just do them one at a time. This is the power rule.
Oh, I understand. It's kind of similar to what we do when we're finding derivatives. You're allowed to separate things.
Yes. In fact, it's more than kind, it's exactly the same
Okay.
rule. So.
I was just trying to figure out what rule you were using because it didn't match, but that makes a lot of sense.
Good question, 2 points. Cool. So now you just do what it says, so. Just to make sure I did not make an inadvertent error, is the correct answer 14/3? Thank you.